Let me write this down. Okay, guys, today we are going to look at natural logarithms. Now, remember, in general, we have like a log base A to the B, and A is the base, right? And A can be anything. A can be 3, 4, any integer. A can be 5, 7, 10, whatever you want it. But there are two really, really common bases, and most logarithm problems you have are going to be either log base 10. And what do we call that? Log base 10, what do we call that? A common log. And in fact, it's so common that if you just say log, L-O-G, of B, and don't put a base, the base is what? 10, okay? And the reason that's nice is because, like, if you have 10 to the 4th and you have log base 10 of 10 to the 4th, that's real easy. It's what? 4, right? Because the 4 comes down and log 10 of 10 is 1. Log A of A is always 1. Log base to the same thing. Log B of B is 1. Log C of C is 1. Log 10 of 10 is 1. So what's really nice is your numbers like 1,000, 10,000, 100,000 come out nice and even if you use a common log. And that's why it is normally used. Okay, there is another very common logarithm, and it's called a natural log, and that is log base e. Okay, do you remember we've used e before, right? E is the, have we used e before?
No.
Okay, thank you. E is the exponential. Okay, it's the e function. Okay, look at your calculator. Okay, look at your calculator. Do you see the e to the x? Okay. If we want to find out what e is, we would put in our calculator e to which power? 1. E to the 1 is equal to what?
2.718.
2.718, and it goes on forever, right? It's kind of like pi. All right. Now, the reason, like you say, how odd. I like log base 10 because that makes sense. What is this e business? Well, e is a magic number. And it's kind of like, if you think of pi as a magic number, e is an even more magical number. And like, no matter where you look in the universe, no matter what rock you look under in the universe, you find e. It's like things in the universe just operate based on this magic number e. So almost any problem that you really use, yes?
What kinds of things were e?
Well, like, let's say if you looked at how bacteria grow. It grows based on E. Like, you know, you start with 1 and the bacteria starts growing. It really starts following a pattern of E. Or if you have a cup of coffee and it's real hot, over time it's going to what? Cool down. And if you look at that cooling curve, the shape of it is E. So things that are growing or things that are dying are based on E. Now, what normally happens with log base 10, like where does the 10 happen? That's more like with money. Like if you were talking about money, you'd talk about $10,000, $100,000, $1 million. That's kind of in factors of 10. So things in accounting and things with money, a lot of times we'll use the common log. But most things in physics or science or biology operate based on E. And so what we call that is the natural log. And that is log base E. Now, you don't have to worry that it's a strange number, because if you look on your calculator, log with no base is the what? The common log. Okay, log base E is on the calculator as ln. Okay, ln of B, what that means is that is the natural log. Okay, and it is log base E of B. But instead of log base E, we just call it ln. Well, the reason we call it ln is that way we can keep it straight, you know, as being different than the common log, which is log base 10. What's the good news? All the rules for common log and natural log, it's like they're the same. It's just when you're using your calculator, you use which key?
The one below it?
Yeah, the ln, not the log. And instead of saying it's 10 raised to the something, it's what raised to the something? E. And look at the calculator. There's an E button, there's an ln button. So those are the two buttons you're using when you work a problem like that. Okay? So lots of things in nature grow according to the equation. All right? Okay, so let's just see if you, like, just make sure you can use your calculator. Like, somebody tell me what E squared is. Logan, tell me what E squared is.
Squared is 7.389.
Very good. Okay, Kelsey, tell me what E to the minus 1.3 is.
Oops.
Mm-hmm. What'd you get?
What was it? 0.272.
Okay, E to the negative 1.3 is equal to 0.27. Okay, so even though E is this long, complicated number, you don't have to worry about it because it's kind of like you know your calculator takes care of that, and so it's a very good thing to do. Okay, well now let's try some natural logs. We're just getting comfortable using the calculator. So what if I had ln of 4? Okay, Jaden, what's ln of 4?
1.39.
1.39. Josie, what's ln of 0.05?
Negative 2.99.
-2.99. Okay, so you see that's pretty easy. We can do the e to the power, or we could do the ln. And the thing that you have to remember is that the ln is log base e. Okay, let me ask you something. ln of 4. How would you do that without using the ln button? How would you do that with the log button?
Oh,
Mario, tell me, it's what? Say it out loud. Yeah, you want to get the right one on top, right?
change of base.
Yeah. So tell me what's on top.
Log.
Log, the common log of
4.
4 over log of what? Of what? E. And so you could just put e to the 1 in the calculator. So see what log base 4 or log log 4 over log of e to the 1. What does that equal? Put it in your calculator. Okay. What'd you get, Mario?
1.39.
Yeah, 1.39. So do you see that you guys could calculate ln without using the ln button on your calculator? You could use change of base. But since you have that button, the ln button on your calculator, you might as well go ahead and just hit ln. But I want you to see you could do it with log if you wanted to. Okay? So let's think of something. Now, if I have log a of a, what is that always equal to? 1. Okay. So if I have e to the x is equal to 5, and I want to solve for x, what is the easiest way to solve for x? Like, what do I would like to do what with the x? Yes?
Have it be like a log of both sides.
Take a log of both sides, then I could bring the x down and then I could solve it. Okay. But which log? Either any log you could do it, but which log would make the problem really, really easy, Levi?
Natural.
Yeah, because that would be ln of e to the x is equal to 5, and then x ln of e is equal to 5. And what, Levi, is ln of e?
1.
It's 1 because ln is log base.
Wouldn't you take the natural log of 5?
Yeah.
Oh, yes. Thank you. I forgot that. ln of 5. Okay. So, Braden, tell me why ln of e is 1.
Because it's base E.
Yeah, it's log base E of
E.
E. And so it becomes 1. So you see, if you have this, the easiest way is to take the ln of both sides, not the log of both sides. So then you say x is equal to ln of 5, and then your calculator can tell you the answer there. All right? Let's do another one. I have 5e to the minus x minus 7 equals 2. And I want to solve for x. Okay, Josie, when I say I want to solve for x, tell me in words what I want to do. Okay, so Josie, what's the first thing you would do to get x by itself? Well, if I did that, if I had this whole thing a natural log, could I bring that x down? No. So I don't want to do that. You got to think, you want to get x what? So what's some stuff I can do right now? Add 7 to both sides. So 5e to the minus x is equal to 9. Okay, Jaden, what would you do now? That's what I would do. Okay, because if I took ln right now, could I bring the minus x down? No, because I got a 5 in there. So Jaden's on the right track, so I'm going to say e to the minus x is equal to 9 over 5. Now, Logan, what would you do to both sides of the equation?
Take the natural log of both sides.
Yeah. ln of e to the minus x is equal to ln of 9/5. And look, I didn't forget the ln on both sides this time. Now, Mario, what can I do?
Now you can bring the x out.
Bring it down, minus x, the whole thing, right? Minus x, ln of e is equal to ln of 9/5. Okay, what happens here, Braden?
The ln E becomes 1.
Boom! ln of e becomes 1, and I have minus x is equal to ln of 9 over 5, and x is equal to minus ln of 9 over 5. So now, you know, and make your answers match what's in the back of the book. I don't know if they leave it like this or if they plug it in the calculator to get an answer, but at this point it's done. Just make sure you do them like in the book, right? So you're getting the, you know, either leave it like this or put it in the calculator depending on what the back of the book answers are. Does that make sense?
Yes.
Okay, so you want to kind of match that. All right. What if I have ln of 5x is equal to 4? What makes this hard to solve for x? Levi, what's hard about it?
Not both sides have a log.
Not both sides have a log, and then also the x is where? It's inside the log. So how would I get the x outside the log, Mario?
Turn to exponential.
Yeah, so this would be e. I can raise both sides to e, right? E to the ln of 5x is equal to e to the 4. Okay. Now, what is e to the ln of anything? What? Well, no, it's what's in here.
No. Yeah.
Okay. So if I have e to the ln of a, that's just equal to what? A. If I have b, and this works for anything where this and the base match. So if it's b log b of a, b log b of a is equal to a. So e to the ln of 5x is equal to what? 5x is equal to e to the 4, x is equal to e to the 4 over 5. And remember, e to the 4 is a number, right? You can put it in the calculator, e to the 5 over 4. Mario, I think I raised both sides to e so you would learn that. What you said is just put it in exponential form. You drop the ln, right? 5x is left, and then the base comes over here, e to the 4. That's what you were saying, right? But did you understand how I did it, just so that you can kind of think of it that way as well? Okay, so let's work one more problem here. Make sure I haven't skipped anything. All right, what if I have ln of x minus 1 is greater than negative 2? Okay, Jaden, tell me why this is hard. Tell me why you don't like that. Yeah, so what would you do? Well, it's not just one side, it's that the x is inside the ln. How could I get the x outside the ln, Jaden? What would I do to both sides of the equation? Yeah, so I'm going to have e to the ln of x minus 1 is greater than e to the minus 2. Jaden, what is e to the ln of x minus 1? X minus 1 is greater than e to the minus 2. X is greater than e to the minus 2 plus 1. Does that make sense? You can put that in the calculator for an answer. Homework is 17 through 42. The bonus is 66.
17 through 2.
17 through 42. The bonus is 66. All right? Get busy.